Hi, welcome to my video on extra surface area problems. This page is, we have to match up the surface area formula with the names. So let's start. Rectangular prism. A rectangular prism has a box shape. So I'll draw a box. Because it's rectangle, then the bottom has a length, a width, and a height. And the surface area of this is the bottom, let's draw the bottom, is a length and a width, which is right there. And there's two of them. And this side here is the width times the height. But that face is also over right here, and there's two of them. And the front side, that's the height right there. The height is the same. The front is the length times the height, and the back side, which is this one right here, has the same dimensions. So there's the formula for the surface area of a rectangular prism. And we look down and we see that it's number 3. A square-based prism is very similar. Same design, shape of box, but the only difference is that because it's a square base, the bottom is a square and it has a height. That means that all the sides, all the faces, or what I say, this one is S and H, and this one is an S and an H. This one over here is an S and an H, and the back one, that's an S and that's an H. So it's an S and an H, but there's 4 of them. And the bottom is a square, S times S. The top is a square, so it's S squared length times width. And there's 2 of them. So the formula for that is, let's look, number 9 is the formula. So that's number 9. It's nice to be able to draw the diagram, and that gives you a better chance of getting the formulas right. A cube is the same as a rectangular box. The only difference is that a cube has all faces, all edges, S's. So that means one face is a square, which is S squared, and all faces are the same, so there's 6 of them. So cube, the surface area of a cube, one face is a square, S squared times 6, and that would be number 5, 6S squared. A triangular prism has the base area as a triangle, and it goes like this. And the triangle, there's half the base times the height, so we have the base, and there's the height right there, base times height. But this triangle over here is the same, so there's 2 of them, and all sides could be equal in length, or they all could be different. So that means the bottom, this is the length. So this rectangle right here is a B and an L. This rectangle right here is a, you can call that a C, A, B, and C, is a C and an L. And the one over here is an A. That's an L, and length times width is A and L. And so that would lead us to number base times height, but there's 2 of them. Or the triangle is a half the base times the height, but there's 2 triangles, so 2 times a half, BH, is just, so a half BH is the area of a triangle, but there's 2 of them, so half times 2 is 1, so there's no 2 there, so 7 is the diagram for the surface area of a triangular prism. A square pyramid, the bottom is a square, and we have a pyramid. So the bottom, because the bottom is a square, is an S and S, the area is S squared. And all what we have here is that this, I could put it here, or I could put it here going down. That's the slant height, L. So the triangle is a half the base times the height, and the base is an S, and the slant height. But there's 4 triangles, so 4 times a half. SH is 2SH. Most people work them out separate for the pyramid, but it's a slant height. The slant height is the distance from the top to the midpoint of the bottom. That's the slant height. The height goes right down through the middle to the base here, but we're not talking about the height of the pyramid, we're talking about the slant height. And the diagram, or the formula for that, is number 2. A right cylinder, here comes a right cylinder, oval in shape at the bottoms. The top and bottom are 2 circles. So the base area of the bottom is a circle, so it's a pi r squared, but there's 2 of them. So that's the base area. One top is a circle, the bottom is a top is a circle, the bottom is a circle. And the lateral area, well, if we took the cylinder and cut it straight down like that, it would unfold to look like a rectangle. But this distance around here, that's the circumference. So that's that distance right there. The top and the bottom is the same. And this is the height. So the formula for the area of a rectangle is length times width. So that's circumference times height. So that's 2 pi r h circumference. So we put that on, because that's the lateral area. And so that's the formula for the surface area of a right cylinder, and that is number 2 circles and 2 pi r h, number 6. A cone is like an ice cream cone, is like this. And a cone has the surface area, the bottom of the cone is a circle, so it's pi r squared. And the formula for this is the slant height, which is, we call the slant height L. And so the lateral area of the cone is pi r L. You have to memorize that one. This is a tricky one to do, and it's hard. I would say you got to do more advanced math to explain why this is working. So that's number 1 circle, and pi r L, that's number 1. And the surface area of a sphere is 4 pi r squared. You have to memorize that one. And the hemisphere's half a sphere is 2 pi r squared. So that would be a number 4 for the sphere, and the hemisphere is number 8. So that's the formulas that you should memorize for the surface area of different geometric figures. Now let's go and work out some applications of that, extra problems. We have a room that's 6 meters long, 4 meters wide, and 3 meters high is to be renovated. So let's make the box shape of the room. There we go. So it's 6 long, 4 wide, and 3 high. We don't have to be exact in the dimensions. It's the length, width, and height of the room. Okay, let's draw the 3-dimensional. There it is. Now it says that the floor will be carpeted at $30 square meter. The ceiling is going to be stuccoed at $5.90. The walls are going to be painted at $43 a can, and a can will cover 35 square meters, and we can only buy full cans. The room has 2 windows, each 1.5 meters long and 1 meter wide. 1 door, 2 meters high and 1 meter wide. If the windows and the doors are not painted, find the cost to renovate the room. Okay, let's start. Let's start with the floor. The floor is right there. So the floor, let's mark The area of the floor is a rectangle, so it's length times width, so it's 6 times 4, 24. And the ceiling is the same dimensions as the floor, so that's 24. And this is square meters because the area, length times width, 2 dimensions. And if the floor costs, the cost to do the floor is $20 a square meter times $30 per square meter. And the square meters cancels out, so we multiply that, we get $720. And the cost of doing the stucco is, the area is 24 square meters times $590 per square meter. And again, the square meters cancels out. When you multiply 24 by 590, you'll get 100. You do that on your calculator, $141.60. Okay, we have the ceiling and the floor done. Now let's work out the walls. A wall is, let's see, this wall right here, this is 3 high. So this wall is this marker walls. We have one wall is length times width, length times the height is 6 times 3, but there's that wall and the back one, so there's 2 of those. And also we have another wall right here, which is 4 by 3, and that one is 4 there, and that's 3 high, so there's a double. So there's 2 of them at 4 by 3. So if you work that out, you get 12 times 3 is 36. And 2 4s are 8, times 3 is 24. So the wall has a total area of 36 and 24, 60 square meters. But we have to remember that we're not going to paint the windows, or we're not going to paint the doors. So the windows are, there's 2 windows, and they're 1.5 and 1. So that's 2 times 1.5, so that's 3 square meters for the windows. And the door is 2 by 1, so it's 2 high, 1 wide, so the door is 2. So that gives us 2 square meters. So the windows plus the door is 3 plus 2 gives us 5. But we're not painting those, so we have to subtract from the walls. The area that we're going to paint on the walls is going to be 60 minus the windows and the doors, and that gives us 55. So we're painting 55 square meters. So how many cans we're going to use? So 1 can is going to cover 35 square meters. And 35 into 55 is 1, and there's 20 left over. So really, we're going to need to buy 2 cans. And 2 cans at $43 a can. So the cans are going to cost $86 to buy the paint. So let's see what we have. But with the total cost, we'll do the floor, we'll do the ceiling, and we'll do the walls. The floor is $720. The ceiling is $141.60 right there. And the wall, to paint the walls, is $86. And when you add all that up and put it all together, you get $947. You can put it on a calculator, or when you add, don't forget to put the decimals in like this and this. You put the dollar signs in if you want. Add it on a calculator, $947.60. Remember, the word practice in my videos means that you pause the video, you work out the problem, and then you press play to see if you got the answers right. And you do that for all these problems. Practice again. Read the problem and work it out. And when you pause the video, When you get it worked out, press play to see if you got it right. 6 boxes, each with a cubic shape, are constructed for a float in a parade. Each box has an edge of 1 meter. If they are sprayed with paint at a rate of 4 square meters every 20 minutes, how many hours does it take to spray all the boxes? Well, we got one box, and a box is a cube, so let's just draw that box. Don't have to, but it's nice to. And the cube is S and S and S. So one face of a cube is S squared, but there's 6 of them. So the surface area of one box is a cube, so 6x, 6s squared. And the edge has a length of 1 meter, so S is 1. So we have the square first to get a 1. 1 times 1 is 1. So one box is 6 square meters in surface area, but we have 6 boxes. And we got 6 boxes, so 6 boxes times 6 square meters. So altogether, we have 36 square meters to spray. Now, let's see. We're spraying them at a rate of 4 square meters every 20 minutes. So the rate is 4 square meters every 20 minutes. So let's write it down as 4 square meters. Let's do it this way. Every 20 minutes. But if you read it, this is in terms of minutes, but we want it in terms of hours. So to convert this rate to hours, we would multiply it by 60 minutes for 1 hour. Notice that I put 6. I could have put, if you want, I could have put 1 hour is 60 minutes. And you would say, well, how do you know if you're going to go 60 minutes over 1 hour or 1 hour over 60 minutes? Well, because minutes are on the bottom in this rate right here, I want it to cancel. So I'll put minutes on the top and hours on the bottom because the minutes is going to cancel out. And that leaves me with meters per hour. So 20 into 20 goes 1, 20 to 60 goes 3. So we get 12 square meters in 1 hour. So we convert it from square meters to minutes to square meters to hour. Now let's do a proportion. So we're going to do area in terms of time. So 12 square meters for 1 hour is, how many square meters we have is 36 square meters over X number of hours. Notice it's area over time. I set up a proportion. Proportion is 2 ratios equal. Because I have the proportion set up, notice that we can cross multiply. We get, notice that these will cancel out when you cross multiply, so I get 12 times x is 1 times 36, and we divide by 12, and we get x is equal to 3. So what's left when you cross multiply, you get the square meters canceling out, so this turns out to be 3 hours takes to spray all 6 boxes. Okay. Practice again means pause the video and work them out and press play when you get them done to see if you get the answers right. The units for this is feet. So all the triangular prism and the square pyramid all have feet. So that's 10 feet, 8 feet, etc., etc. Now, the surface area of the triangular prism is how many times larger than the surface area of the square pyramid? Well, let's work out the surface area of the triangular prism. And when we do, we have a triangle is the front of this. And notice that's an 8. That's 8. That's 8. They're all marked. And notice this triangle is the same. Both ends of the triangular prism is the same. And this edge right here is 10, so that's a 10 there, and that's a 10 right there. So these edges are 10. So one triangle, what happens to get there? We had an 8, an 8, and an 8 for the triangle. We drop a perpendicular from the top here down through. There's a right angle. When we do that, because these two sides are equal, that means the base is split into two equal pieces, 4 and 4. Now, we want to need, in order to calculate the area of a triangle, we need this height. We're not given the height, so I constructed this to show you. And because we did that, we have right triangles, and we used the Pythagorean Theorem, which is used quite regularly in math. And in the Pythagorean Theorem, C squared equals A squared B squared. C is the hypotenuse, which is opposite the right angle. So C is 8, and BA is 4, and we could call this the height. We want the height, so we'll call B the height. 8 squared is 64, 4 squared is 16, 8 squared. And because we're solving an equation, we'll transpose the 16 to the left side and make it a negative 16. That gives us 48 s squared. And let's bring that up here. So h is going to be the square root of 48. And that comes out to be the square root of 48 is 6.9. And again, the units are in feet, so that's one dimension. So that means the area of the triangle, which is a half the base times the height. So it's a half, and the base is 8, and the height is 6.9. And that works out to be, when you use your calculator, 27.6. And the area is 2 dimensions, so it's square. And let's see, we have the base area, but there's 2 of them. We'll work that in the formula after. Now we need to get the area of the faces. And there are 3 rectangles here because they're all equal. So the area of one rectangle is length times width. So that's 3 times 10 times 8. So that's 240. And again, it's in feet, so it's square feet. 30 times 8 is 240. Now, we have the surface area of the triangular prism is base area, add on the lateral area. But the base is 2 triangles, so one triangle is 27.6, but there's 2 of them, and the lateral area is the area of the sides, which is 240. So that gives us 55.2 when you multiply 27.6 by 2. We add on 240 and we get 295.6, and that's square feet. Now we got to figure out the surface area of the square pyramid. And the base of the square pyramid is, a square. And so the bottom is 6, so that's 6, and that's 6, and that's 6. So the area of a square is s squared, so it's 6 being squared, so it's 36. The lateral area is the area of the 4 triangles. Let's get one triangle first. And the area of the triangle is a half base times height. So the base is 6, the bottom of the triangle is 6, and the height, which is SL, slant height of the triangular height, or the triangle height coming down, is 5. Put that 5 in there. SL is 5, and is a square, so it's 6 and 6. So half of 6 is 3, 3 5s are 15. And this again is in area, so square feet. So, but we have 4 triangles. So 4 triangles is 4 times 15. So that makes it 60 square feet. So the surface area of the square prism is 36 plus 60, and that's 96 square feet. And it says, how much is the rectangular prism more than the square pyramid? Well, that means we got to get the surface area of the, let's say, triangle, and the surface area SA of the square pyramid. I just put a square in there without writing it all out. You know what I'm doing. So the triangular prism is 295.6. The surface area of the square pyramid, that right here, is 96. Okay. When we divide that out with a calculator, we get 3.075. And so, how many times bigger? I'd say it's roughly 3 times bigger. So the surface area of the triangular prism is 3 times bigger than the surface area of the square prism. Again, knowing the formulas, working them out, and again, I use Pythagorean. I stress Pythagorean quite often. Now, another neat question here is one pertaining to the ice cream cone. Because the ice cream cone is made up of, this is the cone right here, but the top of the cone is a hemisphere, half a sphere. So you can imagine taking an ice cream cone and putting a scoop of ice cream on the top, and the ice cream on the top is a half a sphere. Now let's work this one out. Again, practice. Pause the video and work them out. An ice cream company has a display like the one above in the front of its headquarters. The display is a cone shape with a hemisphere placed on the top. Each has a radius of 1.5 meters. The height of the display is 3.5 meters off the ground. Find its surface area to the nearest square meter. Okay, first of all, it says that the radius of the cone and the sphere is 1.5. Okay, that's easy. We know that let's work the top and then go to the bottom. Let's do the hemisphere first, and then I'll do the cone after. So we know that the surface area of a sphere, pH, is 4 pi r squared. So the surface area of a hemisphere is half of that, 2 pi r squared. So that means that 2 times 3.14 times radius is 1.5 squared. When you work that out, you get 14.13, and it's square meters. So let's just round that off to 14.1 square meters. So we have the hemisphere worked out, which is half a sphere. Now I need to do the cone. And I have a cone, I have this, I have the height, which is, but the height is from the top to the bottom. So from the top there, right down to the bottom, the whole display is 3.5. So that's 3.5 from there right on down through there, like that. If this is 1.5, then this is also 1.5, because the radius of a hemisphere or a sphere is the same from the center to any point on its surface. That means that if you take the 3.5 and you subtract 1.5, you get a 2. So that means the distance through here is a 2. If that be the case, if you see it, let's draw this. I have this shape. So I have a right angle, I have a 2, and I have a 1.5. So in order to get the surface area of the cone, I need to get this, which is this slant height, L. So if I take this diagram and reproduce it, which I have down here, I have a Pythagorean, c squared, a squared, b squared. Again, I always emphasize. When you have a right triangle with two sides, you get the third side by doing Pythagorean. C is the hypotenuse, so hypotenuse is opposite the right angle, so C is the L. A is 2, B is 1.5. Make any difference with these two, long as you put L to be your C, because that's the hypotenuse. So L squared, 2 squared is 4. 1.5 times 1.5 is 2.25. So L squared is 6.25. L is the square root of 6.25, and the square root of 6.25 is 2.5. And this is in meters, so it's only one dimension. So we need to get the surface area of a cone. So the lateral area of a cone is, again, that's a tricky one. It's a pi RL, which is 3.14. R is 1.5. That's the radius of the cone. And the slant height, we worked it out to be 2.5. And when you multiply all that together, you get 11.8 or 11.775, but let's round it off to 11 to the nearest tenth. 11.8. You round this off, you make these two zeros, and you add 1, because that's 5 or greater, you add 1 to the 7 to get an 8. And there's 2 zeros there, but not need to put it in. And again, that's area, so it's radius is a foot, and there's another, so that's feet times feet, which is square feet. So the surface area of this ice cream cone is the base area plus the lateral area. And the base area is 14.1, and the lateral area is 11.8, and you add all that up, you get 25.9. Total surface area, oh, that's feet, put that in, square feet. Again, working out the formulas, learning the formulas, very important. And I stress Pythagorean again. And we have another one to do. We have the cost to build a large cylindrical stainless steel water tank is $49,063. The tank has a radius of 2.5 meters and a height of 10. What is the cost per square meter to build the tank to the nearest dollar? So, what's the cost per square meter? So that means we have to figure out the cost and divide it by the number of square meters to get the cost per unit. So, let's draw the tank. It's a cylinder. Here comes the tank. Cylinder tank. It says the radius is 2.5. The radius is the point from the center to the edge. The height is 10 meters. It's all in meters. So the height is from top to bottom, and that's perpendicular. Okay, now we need to get the surface area, because they're going to build a tank. So they're going to build all this around the sides and build the bottom and the top. So we're talking about surface area for this question. And so the surface area, let's get one base. The base of the circle is, the base of the cylinder is a circle, so it's pi r squared. 3.14 times the radius is 2.5 squared. The radius is 2.5. And when you work that out, you get 19.6. And it's in meters, so it's square meters. And how do you get the lateral area? Well, if you remember, if you take the cylinder and cut it like this, you got a 10 there, and this unfolds. When you cut it, this right here, which is your circumference, is gone right here. So that's your circumference, and that is the lateral area. So we have to work out the circumference of the circle. Circumference is 2 pi r, 2 times 3.14, and the radius is 2.5. because the circle is this right here, so the circumference of this circle. And that gives us, when we work it out, to be the circle. We can work it all out. That's 5 times 3.14 times 5 is 0.7, so it's a 15.7. And so the lateral area of the cone is, we could have worked it out all together, but we could say it's like that, and it's 15. Pen is run out. Let's get a new one. Excuse me for a second. So it's 15.7 times the height, which is 10. So it's 15.7 times 10 is 157 square meters. Some people would work this out not like this. They would work it out that the lateral area is circumference. They do and they go 2 pi r h, circumference times height. So they go 2 times 3.14 times 2.5 times 10. Most people wouldn't do them individually like this and then multiply. They would work it all together to get 157. So we're building the rectangular tank, or sorry, the cylindrical tank, and the surface area has base area and the lateral area, but the base is 2 circles. So it's 2 times, one circle is 19.6, and the lateral area is 157. So that gives us 32 times 19.6 is 39.2 plus 157. So that's 196.7, and it's square meters. Notice I have 2, the bottom and the top, so I've multiplied one of the circles by 2, and then I added on the side, the lateral area. But we want the cost per square meter. So the cost is, let's see, $49,063 divided by the surface area of 196.7. So that's dollars and that's square meters, and that works out to be 200, when you use your calculator, 250.066. So round that off, it says round it off to the nearest dollar. So the nearest dollar is, that's dollar is, the nearest dollar is here. So that's a 0, 0, 0. This is less than 5, so we leave it. So the answer is $250 per square meter. Is the cost to build this large cylindrical stainless steel tank. Stainless steel is expensive. That brings us to the end of our video. And again, stressing surface area. If you like my video, click on the like button. And if you want to be a subscriber, click the subscribe button. And click the notification, because there's many videos coming your way if you're a subscriber. Write a comment on my video if you wish. And you may also visit my math website, www.mathfullyexplained.com. There you'll find information on me, my videos, and the content. And the content tells you what topics I'm going to have online, and etc., etc. Thank you very much for viewing my video. Bye-bye.